This is example 1 from the 10A notes. And in 10A, what we're going to do is we're going to learn how to use the formula from the Pythagorean theorem. And you guys have probably seen this before. It's a squared plus b squared equals c squared. And if that's all you know, a squared plus b squared plus c squared, it may not make much sense. So it's important to remember a couple things. First of all, let's just take a look at a right triangle. A right triangle is a triangle that has one 90-degree angle. And you'll see that depicted with a little box in the corner like this. It'll just be a little box that'll look kind of like that in the corner. It's not going to be cute and blue, but it will be a little box that will show you that that angle is a 90-degree angle. And when you have one 90-degree angle, it's a right triangle. And that means that you can use this formula to help you find a missing side. So when we look at this triangle, we know that this side is 4 long. This is 6 long. But we don't know how long this is. So we're just going to call it x, okay? And we can use this formula to figure out how long that side is, all right? So the other thing that's important to remember when you're using the Pythagorean theorem formula is that we want to label our sides. This long side diagonal from our right angle, we call the hypotenuse. I'm going to abbreviate it just HYP. These yellow straight up and down and this right angle here, these are called legs. Those two sides that make up the right angle, that's a leg and this is a leg. So this is how a right triangle is labeled. And I really recommend that you always do this when you're working with the Pythagorean theorem formula, because here's the thing about the formula. A squared and b squared only can be legs. You can't ever use the c squared area for a leg measurement. Okay? So a squared and b squared are always the legs. Okay? Really, really, really important, guys. So let's go ahead. Oops. Try to move my little arrow. A squared, b squared are always our legs. And remember, when we're doing this, these terms are squared in the formula. Okay? Now, c squared is always our hypotenuse. So this c squared always has to be the value of that long diagonal side here. Well, how do we use the formula? Well, I've set up a little template here so that I can show you how we're going to do that. Here is where a squared and b squared goes. And so that's where we're going to put the measurement of the legs. Okay, so the first leg, we'll put 4. Now remember, in the formula, it has to be squared. 4 squared. Okay, what about this one? Well, we want b squared, or leg squared. We want the other leg. So we want 6 squared. Okay? Then what about in this spot? Well, it's c squared. It's the hypotenuse squared, but we don't know what that length is. So we'll put x squared. Guys, all of these have to be squared when we're using this Pythagorean theorem formula. Well, at this point, how do we solve for x? We want to simplify this side, okay? What's 4 squared? Well, it's 4 times 4, or 16. Then we want to add it to 6 squared, which is 6 times 6, or 36. And we're still equal to x squared, okay? 16 plus 36 is going to give us 52. So when we add these together, we'll get 52, still equals x squared. And guys, at this point, we're just going to switch them around. Sometimes it's easier when we have that x on the left-hand side. We're kind of used to that. You can always switch sides around like that, okay? Well, now what do we do if we want to solve here for x? This isn't x, this is x squared. So how do we get x when we have x squared? Well, remember in algebra, we always do the opposite to undo when we want to get to our x. So the opposite of squaring is taking the square root. And so to solve for x here, we're going to take the square root. Of course, we always do that to both sides. And that square root will undo the square. So we'll get x equals the square root of 52. And that's how long that other side is. That's how long the hypotenuse is. Now, I'm not going to take any points off if you leave your answer here. But the best thing to do here is to simplify this radical. And remember, the way that we do it is we do that prime factoring, right? So we know that 2 can go into 52, and that goes in 26 times, okay? Well, 2 is a prime, 26 is not, so we're going to divide again. And 2 will go into 26 13 times. Now this time, 2 is a prime, but 13 is also a prime. And once we have those prime factors, 2 times 2 times 13 equals 52. Well, if we have any two factors that are the same, 2 on the inside, 1 can come out, right? So x will equal, remember 2 on the inside, 1 comes out. 13 doesn't have a buddy, so it stays behind. And our answer is x equals 2 root 13. Now that x here is the hypotenuse length, 2 root 13. And that's our answer. All right, guys, thanks for watching.